Here we are, lecture 4 times, so welcome back once again to everybody. So today we're going to talk about objects in Python, and we're going to talk a little bit more about PsychoPy stuff, specifically graphics today. And just a small warning, I'm still getting over being sick over the weekend, so it's going to be a little bit lower energy for me. And I do have my trash can handy in case I need to take a break for a second, because I just had my first solid real meal in like 2 days a few minutes ago. So hopefully it'll stay down, but could be getting exciting here. But hopefully not. Hopefully not too exciting. All right. So so let's talk a little bit about, well, first sort of general stuff. So today, like I said, it's objects and our second PsychoPy session. Hopefully we'll be doing some kind of cool graphics stuff today. Hopefully everyone has by now had a chance to check out problem set number 2. Anybody have questions or anything about problem set 2?
Yes. Question 3.
Which one is question 3? Remind me.
The for loop. I mean, you have to repeat it for 5 times.
Oh, yeah. Okay. All right, well, we'll talk about that. Okay, fair enough. I mean, I can give you some guidance later, perhaps, without giving you the actual answer. But, you know, I would certainly suggest playing around a little bit with Python, see if you can figure it out. Fair enough. Okay, yeah, so I can give specific help later on. Any sort of general questions or other stuff that people are having trouble with? Okay, Chang says she might have caught an inconsistency. If everyone saw the bounty section. I don't know that I have any errors, but Chang says she caught an inconsistency that may qualify, so I'll see you later if that counts. But there may be bounties to be had in this one. We'll see. Okay, so just to let you know, because I was sick this weekend, I didn't have a chance to finish grading problem set 01, but hopefully in the next few days I will do that. Certainly by the time problem set 3 comes out, I'll have your marks for problem set 1. Okay, any other administrative stuff or general issues or anything before we get started in today's stuff? Okay, so there's going to be a little bit of more lecturing today than there was last week. We're still mostly doing demos in the latter part of the class, but I have a little bit of kind of history and background to give you guys on what objects are in the sense of programming and why we care about them and why they're important. So hopefully this won't be too boring, and we'll kind of try to get through it sort of quickly. But hopefully you'll start to see kind of why I told you some stuff earlier and what we're doing here. So if you can remember all the way back to lecture 2, we said something like this in lecture 2 about variables. I told you that, you know, at the very lowest level, the computer is really only doing a few things, like storing information in memory, changing it in some way, and then storing the new information back in memory, right? And that is still, literally speaking, true. So we're going to talk a little bit more about how that's true and why that's true. So, you know, the core of a computer is basically a CPU and memory, right? So the memory holds these numerical codes, and the CPU is a processor, a mechanism for comparing them, adding them together, multiplying them, dividing them, whatever, doing various mathematical operations on these codes, and then store them back into the memory, right? And of course, you also have peripherals that you can attach to let the humans interact with the information in the computer's memory, right? Because otherwise, it's not really that useful to us if the computer's just humming away to itself and not sharing its information with us. So, for example, you can use something like a monitor that lets certain codes in certain parts of memory be communicated into being pixels on the screen, or input peripherals like your keyboard and mouse that basically let you push physical buttons on physical objects and turn those into codes in memory that the computer can then read in memory and do stuff with, right? So we can, as humans, we can influence some of the values in certain parts of memory by manipulating things like the keyboard and mouse. We can read the values of certain parts of memory by looking at output on the screen, but really the computer is still mainly concerned with just all these values in memory and how it transforms them with the CPU. Now the reason I bring this up is because in the moderately olden days, computers were programmed with a very low-level type of code called assembly language. And we talked about this really briefly in the first lecture, but we're going to go into a little bit more detail. And again, it's a little bit boring, but there's sort of a reason for it. So by low level, I mean basically that this computer language is not so close to human speech, right? It's closer to the way the CPU actually operates. So assembly language, or assembly code, as you sometimes see it called, it's basically direct instructions to the processor which particular operations to have the processor do for certain items in memory and where to put the result, right? So you're basically, line by line, telling the CPU what values to look at, what to do with them, and so forth. So there are different assembly languages for different processors. The one on the left is for, I think, the original IBM PC. And when I say the original, like back in the really old days, a PC, there weren't different types of PCs. There was just a computer called the IBM PC, right? So I think this is for the original IBM PC. And I think this one is for like old school Macintosh computers, if I remember right, like the ones circa like the late 80s. And you can see that these languages do not look very user-friendly, right? So it kind of tells you what this one is doing. This is a function that takes in a number in what's in a memory location called AX and subtracts 32 if it's in a certain range of numbers and otherwise leaves it unchanged. And it does little things like, if you can read this, it's a little fuzzy on the screen. It's got little instructions like CMP of AX and 97, which compares AX and 97. The next line says JL done. So that means if it's less, jump to the area marked done. Otherwise, you go through here. So if it's not less, then you would go through the next line where you compare it to 122. If it's greater, you jump to done. Otherwise, you subtract, right? So you can kind of see what this code does. But you can imagine very quickly that like it wouldn't be fun to write a long program in this style of code, right? And similarly over here, you've got similar kinds of instructions where I won't go into the details, mainly because I don't understand them. But what this little program here is doing is simply dividing an input number by a certain other number. I think it's 61. And it's doing this by like pushing little bits of memory around and shifting them around and adding things and multiplying things, and eventually what you get is an act of division. But it's very annoying to have to do that if you just want to divide two numbers, right? It would be better to write something that's more like the way humans like to write things, right? So for that reason, as computers got more and more complex, this became, and as programs we wanted to write got more complex, this became an undesirable way of doing things, right? Because it would take a really long time to do anything complex when you're like micromanaging the processor, when you're telling it every single little thing that it has to do. Although I'll note that people still use assembly code nowadays, especially like if you need to write really, really like super optimized code for like a game or something like that, you would often write it in assembly code because it is sometimes a bit more efficient than something like Python or other languages. But for just general type stuff, you don't write a lot of assembly code nowadays. Okay, so if you can remember even further back to lecture 1, a long time ago, 3 weeks ago, we said this thing about how computers are getting better at understanding human languages all the time, and we're gradually getting to the point where computers can just do what humans tell them to directly in English or whatever your preferred language is, but obviously they're not there yet. And one thing that we're doing is we're using programming languages nowadays that are closer. We're programming each sort of new interface to the computer, using languages that are compromises between human language and computer language, right? But the hope is that as we kind of move along, we will invent computer languages that come closer and closer to natural human speech, and have to spend less time worrying about the details of pushing bits of memory around, right? So if you remember, I had a list of. Sorry if that's hard to read. I don't know why it's a little bit fuzzy, but. Basically, we had a list of what we called low-level languages, like assembly language. And then there were sort of higher-level languages and higher-level languages and so on, right? So nowadays, we have a lot of programming languages that are pretty high-level, still not so high-level that you can just tell the computer to do your homework for you or whatever, but we're getting there. But anyway, the point is, like we said, programming and assembly code got very tedious as the programs became more complex. So people tried to build somewhat more high-level languages. You may have heard of C or Pascal. These were very popular languages, especially like in the 70s and 80s. and even into the 90s and beyond. People still use C a lot today. So they built these languages on top of assembly code. In other words, they invented languages that could be translated into assembly code, but were a little bit more convenient for humans to write, and did slightly more complex things with every line of code, right? So, you know, the idea is that the words in the language and the instructions that it did, they looked more like a human might want to program, more like what a human might want to program to do, and they can do a lot more in one line of code. So you don't have to worry about like every single byte of memory that goes into the processor. You just have to worry about the more high-level tasks you're trying to do, like add numbers together, display information on screen, and so forth. And if you remember when we talked about compilers, this is the job of the compiler, right? Is to take this language that's a little bit more human-readable and turn it into that low-level assembly code that is basically talking directly to the processor, right? Okay. Now, that said, C and Pascal and other languages of that kind of generation still retained a lot of similarities and features of assembly language. And this is why, particularly why I'm talking about this today, they were still focused on the idea of using variables to represent data, and usually that data was in some way or another numerical data, and using what we call functions or procedures to transform that data. So like we said, that's exactly what the processor is doing, where C and Pascal did it in a slightly more high-level way than assembly code, but still the idea is here that you've got memory and you've got a processor, and you tell the processor to do things with the information in memory, using what we call functions in C and Pascal terminology. So this style of programming is what we call procedural programming, okay? Because we use what's called functions or procedures mostly as our structuring element of the language. So if it's confusing to you, we'll talk more about functions and procedures later on in this class, actually, because Python does do procedures and functions, and we've actually used some already, whether you realize it or not. But if you have trouble sort of wrapping your mind around functions, you can think of them as kind of being like, if you remember when we did, well, not we did, but when you did and I did functions in like algebra class, right? If you see a notation like f of x equals x plus 7, you know that f of x, we call it a function, right? And the idea is that you put in something called like x, and you get out a value, right? So if we put f of 5, the answer, or the value of the function would be what? 12, very good. And if I define another function called g of x that was 2 of x, and I put in 5, then we'd get 10, very good. And you could do things, and of course you can, excellent, good work all around. And of course you can do things like combine functions. So hopefully this terminology looks somewhat familiar to you if you can remember way back to your algebra classes. You can do things like f of g of x, right? So you can do g of x and then plug the value of that into f of x, right? So if you work that through for 5, g of x we said was 10. What is f of 10? Well, f of x is x plus 7, so what's f of 10? 17, right? So yeah, so f of g of x would be, f of 10 or equivalently 2x plus 7, right? So that's the idea, is that you can combine these functions, and that's essentially what C and Pascal and languages like that do. You define functions that take inputs, like x here would be considered our input, and they have outputs of some sort, so they have some kind of result. And you can then just like call them in sequence and combine the inputs of one and put it into the take the outputs of one function, put them into the inputs of another, and keep doing that until you've done whatever you are trying to do, right? Another way of visualizing these functions is like an assembly line, right, where you have some function called g, and you have some function called f, and you drop a ball into the mysterious g box, and it comes out a cube, and you drop the cube into the f box, and it comes out some weird, 12-sided die or something like that. So the idea here is, right, is that it's a series of successive transformations of data, right? But the data goes into a function, comes out transformed somehow. You plop that data into a new function, that comes out somehow, and so on and so forth, right? Okay, so the reason we're talking about this is because this is not what we're focusing on today. So, like I said, these languages maintain this like fundamental divide between data and instructions. If you think about the hardware, the data is what's in your memory, and the instructions are what's happening in your CPU. If you think about this in terms of assembly code, The data are always those little memory locations that were on each line of assembly code, and the instructions were these little CPU instruction codes that say things like compare these two numbers or add this number or something like that. And procedural languages, in procedural language terminology, data would be your variables, which you're familiar with variables by now, and instructions would be functions or procedures that operate on those variables. Okay, so that's the history. However, as time has marched on and programs get more and more complex and so forth, it's become popular to use instead what's called object-oriented programming. So that's what we're talking about today is objects as used in the Python language. So it's called object-oriented programming because the idea of object-oriented programming is to write code that sort of mimics the behavior of real-life objects. So if you think about real-life objects, or at least a lot of real-life objects, most objects can both do things and they have information, right? So an object that you think about in the world, has certain informational properties to it that you could represent with variables or numbers or something, but it can also do stuff, right? So they can update their own information, they can interact with other objects. So some examples, like if you think about an object like your toaster, right? So your toaster, you might say, has a lot of information associated with it, right? Like how many slots does it have? What is the current brownness setting of the toast, right? Does it have any bread in the toaster? Is the toaster lever pushed up or down, right? So this is all information that is contained in the toaster object, right? And the toaster has functions that it can do, right? So, for example, the toaster can, most obviously, toast bread, right? So when you toast bread, you obviously change the lever status from up to down. You might have to check to make sure bread's in the toaster. You check the timer setting to make sure that you're using the correct amount of time and so forth, right? So it has information. It can also do stuff, right? Or if you think about a TV has functions and associated information also, right? Like it knows whether it's on or off. It knows what channel it's on. It might know some other stuff, right? Like the brightness setting, the contrast, and so forth. And of course, a TV can also do things, right? Like change the channel or change the volume up or down or so forth, right? So anyway, you can think about real-life objects, toasters, TVs, cars, other people, whatever, desks, clocks, anything you see in this room, you can think of as a package of information and functions bundled together, right? So that's the basic idea. And if you think about computer interfaces, as time went on with the advent of Windows and the Mac OS, the way that you interacted with your computer became a lot more object-like too, right? So instead of just like lines of text on the screen, which is what you had back in like the 70s, you started to have things like windows, right? And a window on the computer screen looks kind of like a real-life object, right? And it's got things like buttons on it. You've got things like menus and trash cans and so forth, and you interact with those like you do with real-world objects, right? So the idea is perhaps it makes sense to try to think of a way to program computers that don't separate the functions from the information, that talk about the functions and the information bundled together into an object, right? So then if you had a window object, this window object would be able to move itself around, would be able to zoom and minimize, it would maintain information about itself, like how big it is, what kind of window it is, like whether it's a dialog box that you have to dismiss with buttons, what kind of stuff it contains, and so forth, right? What program it belongs to, all that stuff. So the idea here is, can we come up with a way of programming that kind of gets rid of that division between variables and procedures, and instead, kind of packages together the things that seem to go with each other. Now, if you can remember, again, back to lecture 1, I realized when I showed you this pseudocode the first time, you had really no idea what you're looking at. Hopefully, if we review this again, it looks maybe a little bit more like the Python that you're familiar with. Now, it's still not exactly using Python style here. This is kind of a mix of several programming languages styles. But one thing I just wanted to point out is that back even then when I was doing the pseudocode, I was sort of trying to plant subconsciously in your head the idea of this object-oriented programming. So if you remember back to that day, we talked about the correct procedures, according to me, of how you should make a cup of coffee if you have to make instant coffee, and what you would do, right? And if you notice, I started off with creating what we would call in programming terms a coffee cup object, right? So I have some function that makes a new coffee cup. And then this cup can do things, right? So like it can add coffee mix, it can add sugar, it can add all kinds of stuff to the cup. The cup can apparently move itself to a place. The cup can check to see whether or not it's full. The cup can inform you as to whether it's well mixed, right? So you can think of a coffee cup object as being something that has, knows some things about itself, right? Like what its contents are, how well the stuff is mixed inside of it, whether or not it's full, things like that, right? And can also do stuff like inform you about its status or change its status and so forth, right? So I use this just to sort of plant this idea in your head, but very shortly today we're going to see how this actually gets used in real Python code. So hopefully that pseudocode is starting to look more familiar. We might revisit it again as we introduce more and more of the ideas that I kind of snuck in there. Okay, so the good news for you guys is you probably haven't worried yet about whether or not the stuff we're writing in Python is object-oriented or procedural, but the good news is they're really not that different. It's just sort of a different way of packaging information. So in fact, you could write any program in the world, in theory at least, in either a procedural way or in an object-oriented way, and you could produce the same. So the ultimate instructions to the CPU are the same, right? So this is really all about making it easier for the programmer. It's not about what the computer actually does, right? So it's just a question of whether it's easier for us to think of our variables and our functions as objects or whether it's easier for us to think of them separately. So it's just convenient for us. And basically what object-oriented programming offers is a greater degree of abstraction. So abstraction in computer science terms is basically the idea of the more abstraction you have, the fewer details you have to worry about for yourself, right? So you'd say something like assembly language, where you're telling the processor line by line exactly like take this little byte of memory, move it here, take this byte, move it here, now add them together, now put the result here. That's a very low level of abstraction. But if we have a higher level of abstraction, and the highest levels are things like if you write an iPhone app or something like that, you use what's called Objective-C, which is a super object-oriented language. You can just do things like make a new window. And it just like makes a new window, and then you're like, window, minimize yourself. Window, check to see if anyone has tapped yourself. Things like that, right? So it's much less oriented on the details and more oriented with the actual objects in the program that people care about. Now, the other thing to mention is that most programming languages we would use today, including Python, aren't fully procedural or fully object-oriented. They have little aspects of both. So most things like C++, Python, what are some other languages you might? I mean, Objective-C is this way to some extent. All the Microsoft ones like C# and so forth. They mostly have object-oriented features, but they can also program in a procedural style. So in a week or two, we're going to talk about some of the procedural stuff, but we won't worry about that for now. The point to make is that these two are not mutually exclusive. So you can have a mixture of objects and procedures in your code, and it'll be just fine. Okay, so now let's talk about objects in Python. So basically, when you're talking about what it actually is, an object is essentially a special kind of variable, okay? So we talked about variables before that could be like integers, they could be strings, right, like sequences of text, they could be Boolean values, true or false. But an object variable is different because it doesn't just usually contain one type of information, it contains a bunch of other variables representing information about the object and what it can do, right? So like the coffee cup object, right? A coffee cup object might consist of a decimal value saying like what % full the coffee cup is. It might contain a Boolean value saying whether or not the cup's contents are well mixed or whether it's full or empty and so forth, right? And then it might be able to do a number of things as well. Now there's a little bit of terminology I'm going to introduce to you just because I'm going to use it today. If you have a variable that's part of an object, it's called an attribute of that object. Okay, and that makes sense, right? Because like if you have a window object in your operating system, the window has a bunch of attributes or features or characteristics, right? Like the size of the window, what buttons it has, and so forth, right? So the variables inside the object are called attributes, and the functions that an object can perform are called methods. And I don't know the history behind that one, it's just the word we use. So a function that is particularly a function belonging to an object, we're going to call an object's method. Okay, so if I use those terms, hopefully that'll make sense to you. Okay, now how do we actually refer to objects? And we're going to get some practice with this really soon, but just to let you know, basically to reference the component of an object, right? Because you can't just call an object, you can't just say coffee cup, right? Like that doesn't do anything. That just gets the coffee cup's attention, but it doesn't, like tell it to do anything, right? So if you want to access the attributes, so if you want to ask the coffee cup something about itself, or if you want to have it do something, you have to access its attributes or methods by using a period or a full stop or a dot or whatever you want to call it, right? So if we have a coffee cup and we want to ask it if it's full, we would say my coffee cup dot is full, parentheses, right? So this would look for a method that the coffee cup implements called is full, and the coffee cup, if it has that method, would come back and say whether or not it's full. Now, if you guys remember back to, I guess this was last week, when we imported modules, this is the same syntax we use when we're importing a module, right? So when we imported the random module so that we could make random numbers, and we used the randint function, we called it random.randint, right? So these aren't quite exactly the same thing, but we use that dot the same way in both cases. So basically what you want to keep in mind is just the dot is essentially our way of saying in Python, look for a thing within some other thing, right? So in the case of randint, it's saying look for a function called randint inside the random module. Here it's saying look for a function called isFull inside a coffee cup object. Does that kind of make sense to people? So the dot is just sort of, you can think of it like, I think we talked about this before, the example was like, you could, in this syntax, you would refer to me as Johnson.Matthew, right? Because in the general Johnson group, there's a Matthew contained within the Johnson clan. So think of it kind of that way. Okay, and the way you create objects is basically by calling very special functions that create what we call new instances of a type of object, right? So, you can have more than one of a single type of object. So, you can have more than one coffee cup, you can have more than one window, you can have more than one of lots of things. So you call these special functions that create new objects when you want to make one. And the first demo here is just looking at the code we made last week, because we already created and used a bunch of objects in our last demo. We just didn't know it yet necessarily. So let's pull up that demo, if you guys don't mind, and just take a quick look at the code we had last week. So if you guys can remember back to last week, see if you can find. All right, so bring up your CyclePy coder. Everybody got your number guess program from last week? I'm sorry, trying to get my windows lined up. So if you can find that again, hopefully you still have this code because we're going to be modifying it today. Get your CyclePy open, get your CyclePy number guess, and if you want a refresher on what it does, hopefully this code still works. I can't remember if I modified it. So it says I want you to think of a number between 0 and 100. Press any key to continue. I'm going to try to guess it. Is it 17? No. Is it 86? No. Remember, it just guesses randomly. No, 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 no. All right, let's say it's 8. Okay, everybody remember this? Hopefully we all got it running last week. So if you look through this code, let's look through here. So the first object we actually create in this code is a window object, okay? So what we did here is we called a special function called window within the CyclePy visual module. And what we did is we created a new window and we told it a few things about the new window we wanted to create, right? Like the resolution of our display, whether or not it's full screen, the units that it's going to use, which are pixels, and various other things. And again, we'll get into the details of what these things are actually doing later on, because we've got lectures on that too. But the main point here is we made a window, and a window is an object that contains a lot of different information, right? And then later on, the window is going to do stuff with itself. So if we go on a little bit, we'll see that happening in just a second. So the next thing we actually do is create a text object, right? So we call this textStim function, which creates a new text stimulus. And again, we gave it some information, like what window it's going to be on, what the actual text is. We told it the font we wanted to use and the height and so forth, right? And here's a good example. So here's our first thing telling an object to do something. Then we called this draw method of my text, right? So we created this text object that has all kinds of information about the text. Then we tell it, draw yourself, right? So we've told you what you are, we've told you what your font is, what size you are, what window you should go on. Now go draw yourself, right? If you don't tell the text to draw itself, it doesn't get drawn, okay? And the next thing we get is we're calling a method of the window, right? So we have this window object, we created it, and we're doing this flip thing. Now I haven't explained this yet, but this is a little bit of what we're doing today. So what this flip thing basically says, and I wish I had a visual to illustrate this. When you do drawing in PsychoPy, what you'll find is it uses what's called a buffer model, where the idea is you might want to draw a bunch of different things on the screen, right? So the idea here is the computer is updating its display all the time, right? So if you just tell PsychoPy to draw something right on the screen, and then you wait like 15 or 20 or 30 milliseconds, and then you draw something else on the screen, and then you wait 15 or 20 milliseconds, and you draw something else on the screen, these things might appear to kind of flicker, right? They kind of come up one by one, because the screen refreshes about once every 16 milliseconds or so. So if you want to draw a bunch of stuff on the screen and then show it all at once, use this buffer method. And basically what it's like is, if you imagine you have like a chalkboard or a whiteboard or something like that with two sides, what you're basically doing is you're drawing all your stuff on one side of the board, and then when it's all ready and you're ready to show it to the person all at once, you flip it around, okay? And so the idea here is you draw all your stuff, or so I guess I would draw it on my side like this. When I've got it all ready how I want to show it to you, I flip it around, and then it automatically erases the other side, so I start again blank, right? So every time you want to draw something in PsychoPy, you're going to want to draw the stuff you want to draw, and then call this flip function, which will actually flip this imaginary board around and show it to the person, right? So you're going to see this flip used a lot. And that's what we're actually doing there, is we're telling you, all right, we've drawn the text on this sort of invisible screen. Now let's flip it around and actually show it to you. Okay, and if we go on, you'll see we do the same thing again several times, right? So we'll create a new text object, tell it to draw itself, tell the window to flip around and show it to you. We'll do that again down here. We'll make a new text object, tell it to draw itself, tell the window to flip itself. Now we do something kind of interesting here. So another little sneaky thing about Python, and we won't get into too much detail on this right now, but maybe I'll ask you about this on the next problem set. One sneaky thing that you can do in Python is, even if things don't seem like they are really objects, you can actually kind of treat most or many variable types as objects. So we talked about strings before, and we just had strings like the one up above, right, that just has, like quotation marks and then some text. But in this particular string right here, you'll see what we did is we had a string, and we ended the string, and then we had .format, okay, which is a little bit weird. And what this is essentially doing is it's saying, all right, treat this string like a string object. And strings can actually do stuff, okay? So what I haven't told you before is that strings can actually have methods associated with them, and they can, for example, include a method like format that lets them format themselves, right? So in this case, what format is actually doing is it's taking this curly brace 0 and replacing that with a number that you specify. And again, we're going to worry about the details of that at a later date. But the idea here is just essentially that objects are not always just things like windows or text stimuli or so forth. You can actually treat very basic things like strings as objects as well. So I know it's not good to treat people like objects, but it is good to treat things like strings and numbers and so forth as objects sometimes. Okay, so that's just like a super quick intro to what objects are in Python. Basically, you want to get used to, the thing that's a little bit weird to get used to is the syntax of objects, right? Because in English, you might want to say, all right, I want to draw some text, right? And that's basically a procedural programming way of thinking about it, right? Is I want to perform the function of drawing, and I want to do it on this text, right? But if you're using objects in Python, and if you're using PsychoPy, you're going to have to, because PsychoPy is very object-oriented. You're going to have to get used to this other way of thinking about it, which is I don't call some draw function and tell it to draw text. I tell the text to draw itself, right? Does that kind of make sense to you guys, the difference between those two? So if I'm thinking about calling a drawing function and passing in text, that's procedural, but if I'm telling the text to draw itself, that's object-oriented. Okay, that kind of makes sense to everybody? Everybody's starting to see? I realize there's a lot of things in the code we've already written that we haven't explained yet, but I'm hoping that things will make more and more sense as time goes on. Okay, so just one more quick little slide here, and then the rest of this is all demos, and we'll see how much we get through today. Actually, I think we'll probably get through all of it, so we might end a bit early, which will give my voice a break. So what we're going to basically do today, so like we said, today's lecture topic for PsychoPy is talking about the visual module of PsychoPy. So we already used a couple of the elements of the visual module, right? Because we just looked at how we created windows and how we made text stimuli. But we're going to make a few more things today and talk a little bit more about how the visual module is put together. So there are lots of other things that you can do with PsychoPy visually. So you can do things like draw images, draw shapes, draw gratings. If you guys can remember back to C82 when we talked about sinusoidal gratings, you can draw those if you want to do low-level visual tasks. You can make rating scales, so if you want people to rate how boring the task is on a scale of 1 to 7 or something like that, you can do that. And you can also play movies. So that's all stuff you can do in the visual class. Today we're just doing a couple of those. So we're going to do some images and some shapes, and we'll leave the gratings and the rating scales and movies for maybe you guys to play around with on your own. That's the idea. So just want to show you guys. So if you find yourselves needing to look this stuff up, this is the whole programming motto of just Google it, basically. What you'll generally want to do if you want to look up documentation on how this stuff works, you can just look up PsychoPy Visual. And I'll show you there's a couple different types of documentation on the PsychoPy website that you want to be aware of. It's basically, hopefully the Wi-Fi will actually show it to us. There's a couple different places that these things are documented on the PsychoPy website. It's just a couple, like this is more formatted as part of the regular website. This is kind of another, I think it's auto-generated reference to the visual module. I know this looks very user-unfriendly and very programming-ish, but hopefully the more Python you get to know, the more comfortable you'll get with this. But basically, if you just Google PsychoPy Visual, you'll see these two references to the visual module, right? And I tell you about both of them because one of the little quirks of using open source software that's under active development is you'll find that sometimes the documentation for one or the other of these is a little bit out of date. So it's often good to like consult both of them because one of them might be a little bit incomplete. But basically what you'll see here is if you're looking up like, well, how do I make a new window and what do I do with the window? Or how do I draw a line? You know, how do I make a new line and how do I make it draw itself? This has all of your options here, right? So if we want to look up how to make an image stimulus, you can just click on this and it tells you various things. Now again, it may not make a whole lot of sense to you right now how you do all of these, but it'll become more and more obvious as we go on. But basically what it's saying is, when you create an image stim, you can tell it all these things, like what image to use, what units to use, where to put it, what the size of it is, what its orientation is, if you want it rotated, all this other stuff. And then it tells you at the bottom kind of what it does, right? So the image can draw itself. You see that right here. You can, let's see, what else can we do with images that's interesting? We can change to a new image file if we want to. We can change the opacity of the image if we want to make it partially transparent. We can change the size, all kinds of stuff, right? And if we look over in psychopy.visual, this is a good example. So this is one where this one's a little bit out of date because the image stem used to be called something else. It used to be called patch stem. So this one's a little bit out of date actually. But if we go to another one, like let's say circle, which we'll use in just a minute, you'll see some other stuff, right? So a circle's a bit simpler because you just tell it what window it's in, what its radius is, how many edges it has, because basically it just draws circles as polygons. 32 should be fine. Like basically the idea is it's hard to draw a precise circle, but you can draw a polygon that's got so many sides it looks like a circle. And you make circles do various things, right? So you can make it draw itself. You can change the color of the circle. You can change the color of the outline of the circle and so forth, right? So the circle's got things like a line color, which is the outline of the circle, and also a fill color, right? So anyway, the point here, and you'll see this, no, I picked another bad one, so this is another one that's not documented over here. But sometimes, so let's say for text stem, you might get information on the other, on this documentation that's not in the other one. So this gives you a slightly more complete description of the various things that you can tell the text stem about itself in this one. So anyway, the point here is just when you get to the point where you're a little more independent with Python, when you're working on your projects or whatever, you're probably going to find yourself going onto the Python website, the PsychoPy website, and looking up like the documentation for this stuff. Just know that there are a couple different methods of documentation available. They're both a little bit, sometimes a little bit out of date, but usually mostly correct. And so you might have to play around a little bit with the various attributes and stuff. But the basic idea here is you go here to find out, for say like a text stem object, what attributes it has, how you can set them, what units it uses, and so forth. Okay. So anyway, that's just to let you know about the website. I will sort of tell you, in today's class how we're going to be referring to the objects we use, but just sort of know that for the future when you start using your own objects. Okay. So any questions about any of that before we hop into some code? Everybody good so far? Okay. So let's do some modifying of this file that we have. So I'm just going to save a new copy. You guys might want to do that too. I'm going to just call mine PsychoPy number guess 2 to distinguish it from the original one. So we're going to just change a few things in this. So, and again, I know that the number guessing game is not so interesting, but we're going to add some stuff to it, and eventually this is going to morph into more of like a psychological task, but we're keeping it simple for now. So I thought one thing we might want to do, if we're playing this dumb little number guessing game, one thing we might want to do is put some, if we're guessing a number, maybe it'll help the person, this is not really a very realistic example, but let's say we want to do this. Maybe it'll help the person to have a visual cue as to what the computer is guessing. So if it's guessing the number 4, maybe we'll put 4 things on the screen so it knows what 4 things there are, right? So let's try doing this. We'll do like one version of this and then maybe take a break here. So let's first start doing lines. Sorry, that's not a good way to say that at all. Let's start drawing lines. So if you think about it, what are some things we're going to have to, if we're going to draw like a little line on the screen for, again, if the program is guessing 10 or 50 or whatever, if we're going to draw 50 little lines on the screen, what are some things we probably want to know about those lines? Like what properties could a line have? When I think about a line that we're going to draw on the screen, what are some properties of lines? Okay, so length is a big one, right? So how long to draw it? What else? Well, if you draw like a line in, I don't know, like PowerPoint or whatever, you can set the length. What else can you set about it? Okay, so you can set the color. We'll worry about the color next. But yeah, so one of them is length, one of them color. What else? Well, how do we know which way we want to draw? Sorry, Rush, were you going to say something or just stretching? Okay, so thickness is an important one, right? Because you could have a very skinny line or a very fat line. And the last one's orientation, right? Because it could be straight up and down, sideways, tilted, whatever. Okay, so to keep things simple, let's say that we're first going to draw some lines that are, again, let's define some of our numbers up here at the top so we can change them easily if we want to. Let's define our width is going to be 4. It's going to be 4 pixels because we set our units to be pixels when we make our windows. So we're going to always use units of pixels right now. So the width is going to be 4. And let's set our length. Let's make it 20 pixels, because I've tried this and this seems to be a nice length, okay? So we'll make lines that are 4 by 20 pixels when we get around to it. So that's just up at the top where we sort of define our overall parameters. And now let's think about where we're going to want to draw the line. So in this file, we create a window, we give some introductory text, like I want you to think of a number, and we say, okay, I'm going to try to guess it now. So if we want to draw a bunch of lines, when it's guessing, we probably want to do it, we probably want to draw all those lines before we actually, or as we're putting up the string saying, is it this number, right? And you'll see how this works in just a second. Again, it's kind of a silly example, but it lets us try out a bunch of stuff, right? Okay, now, like I said, what I want to do in this demo is, if the computer's guessing 5, to draw 5 little lines. And right now, let's say we'll draw them in random locations. Now, if I want to do that, if I want to draw 5 lines or 10 lines or 50 lines or whatever, what kind of structure that we've already learned about am I going to need to use to make that happen? If I want to do something like 4 times or 10 times or 98 times or whatever. All right, well, put it this way. Would it be a for loop or a while loop? I mean, I could use either one, but which one is more suited to this, do you think? You got a 50-50 chance. All right, we might have to review loops a bit then, right? Okay, so you're going to want to use, actually this relates to that question that you asked about on the homework, so maybe this will clarify it a bit. So we're probably, the most natural thing to do here is to use a for loop, okay? Because what we want to, remember what a for loop does is it does something a certain number of times, or it does the loop a certain number of times, right? So we're going to want to put a for loop in here. And what we're going to want to do is we'll keep track of which line we're on. We'll call it line num, okay? And if you remember, hopefully you've looked at the problem set. Before we said range, now for various reasons we're going to use X range. That's part of your homework, is answering why. How many times, so if we're drawing a line for every, like, if the guess is 50 and we want to draw 50 lines, what's the quantity that I'm going to put inside X range here? What's the number in or what's the variable in our code that represents the number we're about to guess? Okay, yeah, it's current guess, right? So what this is going to, whoops, current guess. All right, so what this for loop is going to do, again, is it's going to create X range, creates the range of numbers from 0 up to current guess, right? And it actually stops one short of current guess. So if current guess is 50, it goes, line num is going to go from 0 to 49, right? And so it's going to run this loop 50 times with line num first taking on the value of 0, then taking on the value of 1, and so forth, all the way up to 49, okay? So this is going to let us do whatever we do the number of times represented by current guess. Okay, so now so for each line, we're going to do something. So we're going to have to pick some more information about this line, like where it is, right? And then we're going to want to draw it. So the first thing we'll want to do is we'll want to pick a random location for where the line is going to go, right? So that's going to need an X and a Y coordinate, right? Because obviously your screen has both horizontal and vertical coordinates, right? So if we want to pick where the line goes, we need to figure out where it goes horizontally and where it goes vertically, okay? Now CyclePy represents the center of your screen. It's like in mathematics, the center of your screen is 0, 0. And to the left takes on negative values, to the right takes on positive values, up takes on negative values. I should check this out and make sure I'm telling you the right thing. And down takes on positive values. We can test that pretty easily, actually. Okay, so, but the point is that here is 0, 0, right? So if we're picking a random location, we'll need to pick a random pixel in X and a random pixel in Y that represents where we're drawing the line, right? So let's call it, and of course, the line takes up a lot of pixels, but we want to just pick the center of it for now. So if we say this, let's call the variable this line center X. So I'll first pick an X value. And you guys remember we used random.randint to pick a random number, right? So we can use that again. Now the question is, what range do we want this integer to have, right? So up here, when we did random.randint, we're picking a random number between 0 and 100 for our guessing game. Here we want to pick a random value on the screen in screen coordinates, right? So number of pixels left or right of 0, right? So if I've set, in my case, you guys will have a different display resolution, but if I've set my display resolution to be 1024 pixels wide, what's the range of that center pixel that I could have for my line stimulus? What's the minimum value that it could have and still be on the screen? Okay, I heard it right, 512, right? So, well, minus 512 actually, right? So if my screen is 1024 pixels wide and the very center of the monitor is 0, 0, right? So like that means I can go up to 512 pixels left or 512 pixels right. So my range is going to be negative 512 to 512, right? So what I could do is do this, and that would be okay. So that would work just fine. But the reason we don't like to really do this is because what if I want to, what if I come along and I want to run the same code on a different size monitor, right? So I might remember to change the display resolution up here. And then I need to go down to like find this particular line of the code and change these numbers too, right? So what's nice is if I only have to change one number up here and then code everything else relative to that, right? So what I can do actually, instead of doing that, or instead of doing this where I code the numbers explicitly, is I can say, what do we call the display resolution? We called it display underscore resolution. So we can say, replace that 512 with display resolution square bracket 0 divided by 2. And again, you're going to have to trust me a little bit on some of this because we're getting to some of it later. But basically, what that does is it says, oh wait, did I code that right? I think I did. What that's going to do, yeah, I did that right. What that's going to do is say, we have two values in our display resolution. In Python, just like we do with the X range, so when we say X range of 50 or whatever, it goes from 0 to 49, right? So in Python, you tend to start counting with 0. So if I say display resolution bracket 0, that refers to the first value in display resolution, okay? So what would this one be then? This would be display resolution bracket 1, right? All right, so get used to thinking of, in Python, the first thing is being the 0th thing, and the second thing is being the first thing. It's sort of like as an American, when I'm used to thinking of the ground floor as the first floor, and here it goes ground floor, first floor, second floor, right? So it's just a convention, but just keep in mind that the first thing is 0, and the second thing is 1, actually. Now don't get too attached to this, because in MATLAB, it's going to totally change. But in Python, so the first element of this display resolution is display resolution bracket 0, and then we divide it by 2, right? Because we want to have a negative half and a positive half. So we want to go from negative display resolution 0 over 2, and of course we want the maximum value to just be positive display resolution 0 divided by 2. Does that kind of make sense to everybody? So instead of explicitly saying minus 512 to 512, we want to pick our range, according to whatever the display resolution is. Okay, now maybe I will give you a few minutes to write out how you would, or not a few minutes, but a minute or so, to fill in how you would pick the y coordinate. So this is where this is some random coordinate in the y direction, so the up and down direction. And it should follow that pattern pretty closely. And this is useful, right? Because a lot of programming is copy and paste. So once you understand how one thing works, it's a lot easier to just do it a second time. Okay, so I'll start to write mine as you're finishing yours up. So, of course, it's going to require generating another random integer. And it's still going to go from a negative value to a positive value. But it's going to use display resolution 1, like we just said, and divide that by 2 to get the range on the left side and the range on the right side. Okay, is that what everybody got, hopefully? So just taking the previous line but changing it from the 0th element, really meaning the first element of display resolution, to the 1th element, really meaning the second element of display resolution. Okay, so now we've picked a location for our line. To make it a little bit easier, I had this coded up one way in my notes, but let's make it a little bit more explicit. So one thing you'll notice is that, like, we can do things in Python if I go to my shell for a second. So if I say, like, my display resolution equals, 1024 by 768, right? Now you can do things like, if you want to say, like, what's half of my display resolution on the left or whatever, you can do things like my display resolution 0 divided by 2, or actually I forgot to do it on the negative side, but right, so we could do something like negative that, right? So negative, right, and that's fine. I can always calculate that whenever I want to calculate the number minus 512 from the display resolution, right? But of course, if I'm doing that a lot, it might be easier to just create a new variable called something like left boundary or something like that, and have that be my negative my display resolution 0 divided by 2. So then whenever I want to refer to that number, I can just say it's left boundary. Does that kind of make sense to people? So it's up to you stylistically whether you want to calculate a bunch of numbers on the fly or if you want to create new variables to represent them. There's not always a straight answer. I think stylistically, when in doubt, it's often cleaner to create new variables to represent numbers just because it kind of keeps each line a bit shorter, right? So anyway, the new number that I'm going to have to calculate before I can draw the line is where the line starts and ends, right? Because I've calculated where its center is, but I need to know where its endpoints are. So if I've decided that it's going to be, if these are going to be vertically oriented lines, then the x is going to be the same, right, for both. So if it's a vertically oriented line, it's just going to go from x something to x something higher, right? But the x is going to be the same. So really, if I want vertically oriented lines, I really just have to calculate like the start, let's call it like start point in y, right? So the start point in y is basically going to be the center in y minus what? So if I have the center point of the line and I want to get the endpoints, what do I need to add or subtract to the center point to get the endpoints of values that I've already defined, perhaps at the top of the script, perhaps on line 7. So if I've defined the length of the line to be 20, and I've got the center point, how many pixels above it do I need to go? 10, right? And how many pixels below that point do I need to go? 10, right? So if I want to turn that center point into endpoints, I just have to take the center point in y, which is this line center y, and for the start point, it doesn't really, well, for the line, it doesn't really matter which one we call the start or which one we call the end, right? Because it's going to draw from one to the other either way. So let's first subtract line length divided by 2. Right? Does that make sense to people? Because we start with the point I've defined as the center point, and then subtract half of the length. Now I'll let you do the same thing where you write out where the end point is, so I'll give you a second to do that one. Should be pretty easy. Notice, by the way, I did this little thing that I think is kind of nice. I added a couple extra spaces to make the equal signs line up. And I like to do that, like if I have code lines that are very similar, it's kind of nice to line up their parts so that you can very easily see like how they're similar or different. So you don't have to do that. That's not a feature of the language, but Python lets you do that because it doesn't really care about the spacing inside the line. And it's nice that it lets everything line up. Okay, so hopefully you guys said it's the center point in y plus the line length over 2. Okay? Is that what everybody got? So it's the same thing, just adding half the line length. And now we know, for the moment, we know everything we need to know about these lines. So let's get this last line of code in. Sorry, a couple more lines of code, but one last tough line of code. And then we'll run this and see how it goes. So we're going to need to define a variable. I'll call it myLine, because I called the other ones myWindow and myText. So we'll call it myLine. And we've already imported the CyclePy visual module, right? So we've got CyclePy visual already loaded in because we used it for the Windows and the text stems. So we want to do CyclePy.visual.line is the thing that makes a new line object. Now, again, you're not going to know too much about what we're putting in here just yet. But basically, if you want to make a new line, you have to tell it what window it's going in, what its start is, and it takes the start as actually a 2-coordinate code in parentheses. So you'll actually do it like this. So start equals parentheses this line center x and start point y, right? Because the start point is going to be the center point in x, and then the y coordinate that's our start point. And then it's got a bit of it called end. So maybe, even though you don't know exactly what this is, maybe you can plug in right now what goes in the end portion of this, right? So it's going to be another pair of values enclosed in parentheses, just like it was for start. And I realize it's just after 3, so we'll take a little break once we get this running. Well, a break in debugging session. All right, so hopefully you decided that the endpoint should be this line center x again, and now it should be the endpoint in y. And just to reiterate, I mean, these are just names like start point y, end point y. Those are just names that I picked. You know, you could call them Billy if you wanted to, but these names are more descriptive. Okay, and the last thing is you want to tell it what its line width is, and it's what we simply called, we punctuated it a little bit differently, but we simply called it line width earlier. Okay, so that's pretty easy. And again, we're going to get more into how you know what to give, like what the start equals, end equals, line width equals, what that actually means at a later date. So don't fret too much about that, just as long as you get the basic idea that we're telling this line creator function, basically, we're telling it some stuff, right? Like what window it goes in, where the line starts and ends, how thick it is, and so forth, right? All right, so the last thing we need to do, if we want the line to show up on the screen, anybody have a guess, based on what we've done with other objects so far, what method of the line object we're going to need to call? Okay, I think I heard it right. It's going to be draw, right? So pretty much every, except for like Windows, but pretty much every type of object that you've got in the CyclePy.visual module is going to have a draw function, right? Because anything visual is going to want to be able to draw itself, right? Okay, so that's what we have to do in the for loop, right? So we don't have to do this 12 times or 22 times or however many times, right? Because this series of commands is going to happen however many times our current guess is. So in theory, for every line, it should pick a new random location. It should figure out its start point and end point. It should create a new line object and tell that line object to draw itself. And then after that, we don't really care about what happens to this line object, which is why next time through, we give the name myLine to a new line object and tell that one to draw itself, right? Because once the line is drawn, we can just let it, go away to wherever dead lines go. So that's pretty much it. So does everybody have an idea in their head of what's going to happen when this runs? Let's see. So you can try to run it yourself. Let's hope mine runs without bugs. All right, everybody think they know what's going to happen? Let's see if you're right. Hey, look at that. We got 49 little lines on the screen, in theory, that are hopefully 4 pixels wide and 20 pixels tall, right? It's going to be a little bit hard to check this in some cases. Let's pick a, oh, good. All right, so is it 1? There's 1 little line. Let's see, let's try to get another lowish number. Is it 9? Are there 9 lines there? 1, 2, 3, 4, 5, 6? Yeah, so this is another thing I'm thinking about putting on your homework. So one of the lines ended up in here, right? So it'd be kind of nice if we could alter this code not to pick locations towards the middle of the screen. So maybe I'll have you modify this code to do that in the homework. But yeah, there should be 9 lines on the screen. It's just sometimes they may be hard to find, right? And sometimes they might even overlap each other. So you have to be careful about that. Okay, so anyway, every time I say no, we saw there was a 0 in there, so it drew 0 lines, so that's good. All right, so everybody got that working, maybe? Anyway, so I'll just tell it yes, right? So like, oh yes, you've correctly guessed that it's 8. And it ends the way it ended before. Okay, so do we want to take a, well, does anybody have any questions for posterity before we kind of take a break and walk around and debug? Okay, well let's start up again. So just before we go too much further, we'll note a couple things. So the most common issues people were having were a couple people hadn't defined one or both of these things up here. And again, the idea here, what we're doing up here in this settings section, we're just creating variables, right? And this is sort of a funny situation, right? Because we're creating variables, and they're called variables, but we don't really intend them to vary much, right? Because we're setting them up here. We're saying like we want our line width to always be 4, we want our line length to always be 20. So although we're calling them variables, what we're really just doing is giving names to numbers, so that then if we want to use those numbers a bunch of times throughout our script, we don't have to do a find and replace for that number every time, right? If we want to change it. So we can just define the name once and then use the name every other time, right? Does that kind of make sense to everybody why we're doing it that way? And other programming languages actually have a way to do that without defining variables, but we won't get into that too much. So that was one issue. So if you refer to the name line width or line length, you want to actually have defined it. A really common bug people were having was not closing off this parentheses or this bracket here, or these parentheses. So this is, if you program a lot, this will haunt you every time you program, is you will always miss a parenthesis or a bracket. So that's totally cool. This happens to the best of us. But the point to keep in mind is just that to understand that when you open a parenthesis, you have to close it again, right? And hopefully that makes sense to you. We'll explain a little bit more in future sessions because I know we haven't really talked about what these parentheses or brackets mean. So we'll talk about what exactly you're doing within these parentheses, but the main point is, whenever you open one, you have to close it. And the other common thing was that a lot of people didn't capitalize this L. And as you found out, that matters, right? Because Python is case sensitive. So in CyclePy, all of the object creating functions like line and where's text stem? So text stem up here, they all start with capital letters. And again, this is just a convention. Like there's no rule that it has to be that way, but my convention is usually that I define all my variables. Like when I like to define stuff, I like to name them with all lowercase and use underscores to separate, the words in each variable name. But for example, this is another common style, right, is to use capital letters and to capitalize things without using underscores. So both of them are totally acceptable styles, but the main point is that if it's called, in the Python document, or sorry, in the CyclePy documentation, if it's called line with a capital L, you have to use a capital L. It doesn't work with a lowercase l. Okay, so any other questions or anything before we go on? Okay, so hopefully if you understand that, kind of understand that at least, this next thing we do, so we're just going to do a fairly simple change to this before we move on. So one thing that you may have noticed is that, it's not very interesting to just draw a bunch of white lines, right? So it'd be nice if these lines had some color to them. So we're just going to add a bit of color, I think. Let's get my thing up for how to do it. And now, one thing you have to know in CyclePy, and this is another case where you would consult the documentation. So if I go back to the documentation, let's say I want to go back to the line documentation and see how to set the color. And oh, and by the way, I was going to mention this. I saw Vrush had, like a proper British man, he spelled center C-E-N-T-R-E, which is totally fine. I would just want to mention that, like, I will tend to spell it the American way, not just because I'm American, but also because most programming languages tend to take the American spelling and things. So you'll notice that even though CyclePy is coded up by people at the University of Nottingham, UK, they still spell color the American way, C-O-L-O-R. So that's just worth knowing that, like, because Americans rule the world, of course, in most programming languages, if there's a difference between American and UK spelling, you tend to use the American spelling. So just watch out for that. That might be, more intuitive to some people than others. Okay, so if we look at the documentation for how to change the color, we might actually have to go into this documentation to see, let's see, where's our line? Well, this is a little annoying, right? Because we don't have a line stimulus here. And this one doesn't tell us exactly how to set the color of the line. But what we can do, it says use set line color. All right, so let's go down to set line color. You have to try a few things sometimes. So it says you have a color and a color space, and then some other stuff that we don't really care about. See set color for how to use this function. So you might have to jump around a bit in the documentation if you're doing this from scratch. But basically what you'll find eventually is that colors are specified in, here we go, in a variety of ways, right? So one thing you can do is you can name colors, right? So now, it doesn't know every color in the world, white, royal blue, etc., but there are certain standardized colors that you could use. You can use, if anyone's done HTML, you can do HTML-style color coding if you really want to. But the way that we're probably going to want to do it most of the time is to use what's called RGB color. Here's an example of that. Meaning, we're going to set the redness, blueness, and greenness of the color separately. So you can specify these a couple different ways. So the one we'll use today is just red, green, and blue can all vary from -1 to 1. So the idea here is that 0, 0, 0 would be like a medium amount of red, green, and blue, which would be gray, right? If you guys have played around in Photoshop with the red, green, blue color picker or things like that, this might make some sense to you. Or if you remember your C82COG color lectures, this might make some sense. But the idea here is that you can specify any color that a computer can display by the relative amounts of red, green, and blue in the color, okay? So I'll walk you through how we actually do this. So you'll hopefully see how these are represented. The points to keep in mind for the future are there are other ways you could represent color in CyclePy, but we're going to do it this one particular way. All right, so before we draw the line, let's insert a couple new lines of code. So basically what we're going to want to do is pick let's spice things up by picking a random color for each line, okay? So before we draw the line, let's make a new variable called myLineColor, with or without the U, whichever you like. And again, this is I'm hiding some stuff from you because we haven't gotten to it yet. But this is going to be 3 elements enclosed in parentheses or brackets. Okay, so it's going to be a red, green, and blue, but we're going to package them all together in a kind of triplet variable with all 3 packed into the same variable. Okay, so what we're going to do that is use our random module. So what have we used so far in the random module? What function have we used? Yeah, we've used the random int, right? So up here we used randint, right, which generates a random integer. Now, if we're using a color representation that represents the colors on a scale from -1 to 1, we don't want a random integer now. We want a random decimal number, right? So let's demonstrate what we're going to do on the command line. So if you don't have to do this, but let me just show you. So if I import the random module so I can demo some commands down here. If I do random.rand int, you've already done this before, right? So if I want to do between 1 and 5, it gives me a random number between 1 and 5. But if I just want a random decimal value, I can use one called random.random. Okay? Now, oh, that's very close, actually. So what range do these look like they're coming in so far? What it looks like the maximum and minimum values are of this random number. Yeah, it's 0 to 1, right? Or else it's a, or else it would be a low chance that we wouldn't have gotten a negative number or anything else yet, right? So random.random, which I know is a little bit weird to repeat like that, that's going to give us a random decimal value between 0 and 1, but we actually need a random decimal value between -1 and 1. So what would you do if you had a number between 0 and 1 and you wanted to transform that into a number between -1 and 1? Does that question make sense to you? So if I have something that randomizes numbers in the range, so I don't have another function that's called random positive or minus, -1 to 1. But if I can get just any old random decimal value, I can transform that into a random decimal value with a different range, right? So what would I do to do that? Anybody got ideas? Well, let's make the problem a little bit simpler first. So if I have random.random, and I want to, let's say instead of the range from 0 to 1, I want to get a random number from 0 to 2. So what could I do to that number that comes out of random.random to change it to a random integer that could be between 0 and 2? Okay, so I can just multiply it by 2, right? So if I do this, so the asterisk is how you multiply. I don't think we've actually done this yet. But if I multiply it by 2, and I type this in a few times, now I'm getting random numbers between 0 and 2, right? Because all I did was I took a random number between 0 and 1, and I doubled it, right? So now I've got a random number between 0 and 2. What if I want a random number between -1 and 1? What do I need to do to that random number in the range 0 to 2 to make it a random number from -1 to 1? Well, what's the difference in the range 0 to 2 and -1 to 1? Come on. Don't be shy. All right, it's just a difference of 1, right? So if I take that and subtract 1, let's try this out a few times. Okay, there we go. So now we've got some negative numbers, some positive numbers. Everybody see how that works? So we're taking a random number between 0 and 1, doubling it to get a random number between 0 and 2, and then subtracting 1 to get a random number between -1 and 1. Does that make sense to everybody? All right, so that's basically, if you program a lot, you're going to be doing this a lot because you'll often need random numbers in a certain range. There's not a separate function for every type of random number you might want, so you're often going to have to multiply it or subtract a certain amount or add a certain amount in order to get the random numbers in the range you want, right? So what we want is random.random, if we go back to the actual code, times 2 minus 1, right? And if we want to totally make sure, you notice here that these stay decimal values, but if we want to totally make sure that everything is a decimal value, you could play it safe and call them 2.0 and 1.0. Because you remember there's that issue of if we have 5 divided by 2, it comes out as 2, right? Versus 5 divided by 2.0 comes out as 2.5. So generally speaking, when you're doing computations, if anything looks like a decimal, it all stays decimal. But if we want to be sure, we can call everything 2.0 and 1.0 just to play it safe. I mean, it shouldn't change, but I get paranoid about these types of things, so it's fine. Okay, and I said we want a triplet of these numbers from -1 to 1, right? Because we want to represent a red value between -1 and 1, a green value between -1 and 1, and a blue value between -1 and 1, right? So all I should have to do is paste that 2 more times, that sorry, I'm pointing at the screen like you can see my finger on the screen. That random.random times 2 minus 1, so we'll have 3 of those, right, to generate a red, green, and blue. And if you remember, I said that we're going to enclose these in parentheses for reasons that I have not told you yet. So remember to close it with parentheses. And then, oops. And then we're going to just want to do one more thing. And this is pretty easy to do. So we're going to take my line, and we're going to tell it to set its color to something else. So you notice when we created a line, we didn't at first tell it what color to be, right? So apparently the line creator, when you just create a line and don't tell it, it just assumes you want your line to be white. But that's pretty boring, right? So instead, we could tell it to set its line color to something else, right? So we're going to tell it to set its line color to my line color. Now there is one other thing we need to do, which is tell it, remember I said there are different ways of specifying colors, right? We call these color spaces. So we're going to need to tell it our color space is equal to RGB. And that was that thing, right, where it could have been HTML colors, it could have been word names for colors, but we're going to use the RGB color space where we specify a red, green, and blue value. All right, so that's just 2 lines we added to our code. And now let's see, hopefully, if we did this right, we get something a little more interesting. Hey, ooh, pretty. All right, so now we should have a bunch of colors. Do other people have that as well? People crashing? All right, do we want to take a quick debug break? Okay, so we've got a few more minutes left. We're gonna zip through these next couple of demos because I want you guys to get exposed to them, but maybe I'll let you play around with these more in the problem sets. So everyone has now drawn lines, right? I'm gonna just save this, and you may want to also. I'm gonna call mine number guess 3 now, CyclePy number guess 3, because now we're going to change these lines to circles, and we're gonna draw circles instead of lines. Just try, I know it's exciting, but try to stay calm. Okay, so the cool thing is we can reuse most of the code we've already used for lines, right? Because, you know, we've already done some of the hard stuff like picking the location, picking the color, and so forth. Now, one thing to keep in mind is we're going to have to replace our line width and line length, right? Because to specify the size of a circle, we don't need to specify a width and a length. What do we need to specify? Like, what defines the size of a circle? Okay, yeah, diameter or radius, whichever you want, right? So I'm going to do it by radius, because I think that's how CyclePy does it. And I think 12 pixels should be a nice size. So we're going to make some circles with radius of 12. So you can just get rid of those line length lines. And let's see, so we only need to replace a couple things, right? So we replace that. And then what we're going to want to do is here, well, first of all, we don't need a start point and an end point anymore, right? So we can get rid of this, right? Because a circle has a center, and it has a size, but it doesn't have a start or an end point. Okay? Now, what we're going to want to do then is just change, and just make sure I'm doing this right. We're going to want to change this psychopy.visual.line, and you might be able to guess that the way that you make a circle is by calling psychopy.visual.circle. Now the things you feed in are a little bit different. So you can keep my window, because you always, pretty much whenever you create a new visual stimulus, you tell it what window it's in. But the difference is, let's get rid of everything after, let's just get rid of all this stuff and do it again. So the other stuff you tell it is different from a line though, right? Because you want to tell it, let's see, for a circle it's going to be, so you tell it the radius of the circle, and whatever you called the variable up here, so we called our circle radius, right? So we tell it it's on my window, its radius is going to be what we define the circle radius as, and it's got a third parameter, or it's got a third setting called pos, which is just position, and the position's just going to be the center of the circle, right? So fortunately, we've already defined the center of the circle. We defined it up here, right? Although, you know, we could keep this called this line center x, but that wouldn't be very good coding, right? Because it's kind of lying to call it a line center. So let's call it this circle center. That's just renaming, right? Again, we could call those Jack and Jill for all we care, but we may as well name them things that reflect what they are, right? And while we're at, we may as well change the name of what was the line stimulus to a circle stimulus. And the position, so anyway, the position is just the circle center in X and the circle center in Y. So just like we did with the colors, we're going to put those in parentheses or round brackets and say this circle center X, this circle center Y. And that's actually all we need to tell the psychopy visual circle function. Remember to close that off with a parentheses at the end. Okay, so we just need to tell it what window it's in, its radius, and its position in X and Y. Now if we want to set the colors randomly like we did with the lines, again it's probably good form to change the name to my circle color instead of my line color. And again change this to my circle because we renamed the line to a circle. And there's a slightly different method that we're going to, so a circle, we don't care about the line color. With the circle, we care about what the interior is. So we're going to change the fill color. So this method on a circle is called setFillColor. And then we're just going to change the name of what we're changing it to my circle color, right? Just because we renamed everything. And then change it to my circle.draw. And that should be all we need to change, right? So most of that was just renaming. And we took out a couple lines we didn't need. And then we changed how we defined the circle, and we changed line color to fill color. And again, if you wanted to be sure of that, you could go back to the Psychopy documentation and look up a circle, and you could go down and see, you know, how you would set. You're like, all right, let's see. Oh, look, here's how I set my fill color. Okay. So anyway, if you run that now, what you should have, in theory, if I got it all right, oh, that's even prettier. No, 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 no. Is everyone getting some nice polka dots here? By the way, as a side note, and maybe I'll make this a homework question, we'll see. Try hitting another key that's not Y or N. Oh wait, actually, hang on. Oh, you know what, I forgot. Your code is different, or sorry, this code has actually fixed that bug already, so maybe I won't ask that question. In my demo code that I was writing out, I still had the bug in here where it, well, it's a question of whether we treat any non-yes responses no, right? So in this code, it looks like I am. All right, so has everybody got little circles popping up? People get that? Do you want to take a quick debug break? For anyone that didn't hear or have that error, one error, I mean, you're going to hit it again and again, is the error of not closing off your parentheses. So a lot of people didn't have this parenthesis closed off. And again, I haven't really told you fully like what we're doing with the parentheses when we're using them, so you don't really need to fully understand it just yet. But you do need to make sure every opening parenthesis has a mate, has a closed parenthesis, or bracket if you call it brackets, because otherwise your code just won't compile or won't be interpreted correctly. Okay, so one last thing I want to show you guys before we wrap up is we're going to draw pictures now. Yay! So I put, if you guys want to go to the Google Drive, if you want to do this, you may or may not have noticed that yeah, if you go to the Google Drive, is.good/C83PFP, you see I put a little image in there, the smileyface.png. If you want to download that and put it in the same directory as your code file, we're going to be using that in just a second. Okay? So I'll give you just a second to do that while I review my notes and make sure I know what I'm drawing here. And the good news is, once again, this isn't going to take a whole lot of changes from a circle. So this is what's sort of nice about the way everything is coded up, because most of these CyclePy.visual objects have a pretty similar structure, so you don't have to change much to go from circles to images or whatever. So one thing we do have to change is we have to tell it what image file we're using, right? So instead of the circle radius, we don't need to tell it a circle radius anymore, because it's going to get the size of the image from the image file. But we do have to tell it the name of the file, right? So smileyface.png. And the good news is CyclePy will read in most common image formats. So JPEGs, GIFs, TIFFs, PNGs. I think most of the BMPs, most of the ones you would ever have on your computer, it should be able to read. So we're going to define a string, right, with the name of our image file. And now we're going to go down here, and again, we don't really need to change this part except to make it like reflect what it really is. But we're still going to define the center of the stimulus, but now we'll call it this image center, X and Y, right? And now we are going to have to change a few things here. So my circle is going to become my image, and we may as well just delete the rest of this line because most of it's going to change. So, well, actually, we could keep some of it. Not a whole lot's going to change, but it might be easier to retype it. Okay, so this one's going to be called CyclePy.visual.imageStim, capital I, capital S. Again, this is all documented in more detail on the CyclePy website. But just like before, we're going to start off telling it what window it belongs to. The next thing we have to tell it is that its image is what we defined as image file, right? So what we're really saying is to use smileyface.png, but we renamed smileyface.png as image_file, right? So that just gives us a variable name that we can use to refer to that file. And the only other thing we need to tell it is the position, which is actually the same as before. So it's just pos equals this equals parentheses this image center X, comma, this image center Y, close parentheses. And what else do I need to type on this line before I'm done? Another close parentheses, right? Or close brackets. Okay, so really all we changed was that middle stuff we changed from radius to image file, I guess. So that's not too bad, right? And then we don't actually need the color stuff anymore, right? Because the colors are already in the image, so we can just get rid of that. And then we can just tell my image, go draw yourself. And that's it, right? So that's actually, you'd think drawing an image is really complicated compared to like drawing a line or a circle. But in terms of lines of code, for you, it's actually a little bit less, right? Because you don't have to give it as much information, because a lot of that information is in the image file. And now if we run that, hey! You guys all right? Try not to hurt yourself. It is a contact sport. All right, so now we've got 75 smiley faces. Now we've got 38. Now we've got 51. Now, oh, no smiley faces. 67.5. And anyway, now I didn't give you guys these images, but just to cap off, I would like to make the point that it's nice to put your parameters at the top of the file, because you could have pretty much any image in the place of this. So let's say I went onto our website and got the headshot of one of our staff members, for example, and made an image of that. Then, you know, Peter Mitchell could ask you what number you're guessing.
So creepy.
Yeah, it's a little terrifying. So you see how easy it is to reconfigure your code. And just to be fair, I did mine as well, so that Peter doesn't think I'm making fun of him. So you can also do it with me or any other image that you have on your computer. So that's a really creepy image of me. So you can go on. All right, enough of that. So, all right. So anyway, the point is, I didn't give you those for obvious reasons because I didn't want to give you that power. But you can see how easy it is if you just change one line of code at the top of your file, you know, to switch the stimuli to whatever you want them to be. Okay, so that's pretty much it for today's demos. So does anybody have any general sorts of questions or anything? Any sort of overall questions? All right, in that case, so I'm going to stop for the purposes of the podcast. Like always, we can continue to debug and play a little bit. But, you know, what I would say is just, you know, don't, when you're doing your problem sets and stuff, I will try to revisit some of these concepts. But, you know, it would be useful for you, I think, to go through these demos and just sort of see what you understand, see what you still don't understand. Because some of this stuff will make more sense as the weeks go on, but I do want you to kind of basically understand how this works, so when it comes time to write your own code, you're not totally in the dark. So anyway, so I know we go kind of quick, but I hopefully that gives you enough of a tour of the visual module that you can kind of learn to do some of your own stuff too. And yeah, I think that's it. So, all right, so podcast over, and we'll see you guys next week.